Welcome to today's episode. We'll be diving in the world of spider silk. One of nature's most versatile and surprising materials. For centuries, humans have been fascinated by the incredible qualities of spider silk, and now scientists are finding ways to create it for our own use. Spider silk is a biological marvel. It's stronger than steel of the same weight, yet lighter than cotton. It stretches without breaking, resists damage from temperature swings, and is even biodegradable. In nature, spiders use it for everything from building webs, catching prey, wrapping their eggs, or even parachuting through the air. The combination of high tensile strength and elasticity is what makes spider silk so special. Usually materials excel at one thing or another, but spider silk has both properties at the same time, making it an engineer's dream. So how does it work? The secret lies in its protein structure. Spider silk is made up of long chains of amino acids arranged in a very precise way. You could think of it as like a rope that's made of both metal rods and a stretchy bungee cord that's woven together. This gives it a rare balance of toughness and stretch. But here's the challenge. Harvesting spider silk on a large scale isn't practical. Unlike silkworms, spiders are territorial and sometimes eat each other. That makes spider farms a little complicated. Even if we could keep thousands of spiders in one place peacefully, they also only produce a very small amount of silk. That's where biotechnology steps in. By taking the genes responsible for silk production and inserting them into microbes like yeast, bacteria, or even plants, scientists can trick these organisms into producing silk proteins. Then these proteins can be spun into fibers using techniques similar to how spiders do it naturally. This breakthrough means that we can make spider silk without the spiders, and that opens up huge possibilities in the textile world. Imagine clothes that are light, breathable, and almost impossible to tear. In aerospace and automotive engineering, silk-inspired composites can make vehicles lighter, more fuel-efficient, without sacrificing safety. In the military, you could use flexible body armor that's both protective and comfortable. And in medicine, spider silk sutures are not only incredibly strong, but also have biocompatibility, meaning the body won't reject them. Another thing that spider silk can be used for is fishing lines and nets. Traditionally, fishing gear is made from plastic that can last decades in the ocean, harming wildlife after it's lost at sea. But spider silk could be a good alternative as it's strong enough to use, but also harmless if it gets lost at sea because of its biodegradability. Some companies are making shoes that are lighter, better for ultra runners. Some are making long-lasting climbing ropes, tennis racket strings, or even bicycle components. The fact that it's renewable and biodegradable means it could be used towards anything and push industries into a more sustainable. Leading the change are companies like Bolt Threads, who have developed microsilk for cloth and accessories, and Craig and Biocraft Laboratories, who've used modified silkworms that produce silk that's actually closer to a spider's silk proteins. Nature has had billions of years to refine its designs, and spider silk is proof of that perfection. By studying it, we're not only copying nature, but we're learning from it. Of course, there's still work to do. Producing spider silk at an industrial scale, at the cost low enough to compete with synthetic fibers like nylon, is still a challenge. Future improvements might involve better genetic engineering techniques, new spinning methods, or even hybrid fibers that mix spider silk proteins with other sustainable materials. Thank you guys for listening.